Quantum entanglement is currently weaponizing the deep web, rendering traditional surveillance obsolete through unhackable lattice-based shields. We are dissecting how these untraceable photon-encrypted tunnels bypass global intelligence grids, effectively erasing digital footprints. This shift creates a permanent dark zone where data exists in a state of absolute, impenetrable mathematical sovereignty. The era of digital surveillance just hit a dead end, and global intelligence agencies are powerless to stop it. As of 2026, the deep web has deployed unhackable lattice-based shields that use quantum entanglement to erase digital footprints instantly. Your data is moving into a permanent dark zone of absolute mathematical sovereignty. What if I told you there's a way to send a message without using the internet, without satellites, without cables, and without leaving a trace? No packet logs, no fiber taps, no metadata trail. And the moment someone tries to spy on it, the message destroys itself. Welcome to Dose of Dossier. I'm the informant. Tonight, we're breaking down the physics behind what researchers are calling untraceable photon tunnels. Segment 1: Entanglement. The foundation to understand photon tunnels, we start with one of the strangest phenomena in modern physics: quantum entanglement. When two photons become entangled, their properties become linked, permanently correlated. Measure one, and the other instantly reflects a corresponding state, even if separated by vast distances. Einstein famously called it spooky action at a distance. But here's what makes it powerful for communication. In classical systems, copying information is easy. In quantum systems, it's impossible. The no-cloning principle prevents anyone from perfectly copying an unknown quantum state. And more importantly, measurement changes the system. Observation isn't passive, it's destructive. If an eavesdropper attempts to intercept entangled photons, the quantum state collapses. The statistical correlations shift. The anomaly is immediately detectable. This is the foundation of quantum key distribution systems already being tested in places like China and across the European Union. The security doesn't come from encryption algorithms. It comes from physics itself. Segment 2: The birth of the photon tunnel. Now imagine expanding this concept. Instead of sending data through routers and fiber optic cables, two distant nodes share entangled photon pairs distributed in advance. When a message needs to be sent, both ends perform coordinated measurements on their entangled particles. Nothing travels between them in the traditional sense. No packets, no IP address trails, only correlated measurement outcomes. This is the theoretical basis of what some researchers describe as photon tunnels. A point-to-point quantum link where communication emerges from shared quantum states rather than transmitted signals. It's not a tunnel in space. It's a tunnel in correlation. And that leads to something even more elusive. Segment 3: Ghost routing. In traditional networking, data moves through physical infrastructure, undersea fiber cables, data centers, switching hubs, internet exchange points. Every step leaves metadata. Every hop is traceable. But ghost routing bypasses all of it. In a photon tunnel system, the meaningful information is reconstructed at endpoints using entangled correlations and a minimal classical verification channel. There's no routing table to inspect, no backbone provider to subpoena, no packet stream to duplicate. The route exists only between synchronized quantum endpoints. It's less like sending a letter and more like two vaults opening simultaneously because they were built with matching internal mechanisms. To global surveillance systems designed around fiber tapping, there is nothing substantial to intercept, because nothing conventional is moving. Segment 4: Why intelligence taps fail. Modern intelligence agencies rely heavily on fiber optic interception. Signals are split. Light pulses are copied. Traffic is mirrored silently at backbone nodes. But quantum signals resist this. Attempt to split a photon? You alter it. Any interception attempt introduces detectable error rates. Once the error threshold exceeds a known quantum limit, the communication session aborts automatically. In other words, you can't tap what never truly travels. Locked with key, and you can't observe what changes the moment you try. Segment 5: The real-world limits. Before we declare the internet obsolete, reality sets in. Quantum entanglement is fragile. Photons decohere. Fiber absorption weakens signals. Atmospheric interference disrupts transmission. Maintaining stable, entangled links over global distances requires precision optics, cryogenic detectors, and advanced synchronization. This isn't consumer technology. Not yet. But experimental quantum networks are already being tested between cities, satellites, and research facilities worldwide. The groundwork is being laid. Closing. The invisible future, the next revolution in communication may not be faster. It may not be louder. It may not even be visible. A network where messages can't be copied. Interception reveals itself, and routing leaves no trail, not because it's hidden, but because it operates on the fundamental laws of reality itself. This isn't science fiction. It's applied quantum mechanics. And if photon tunnels mature into scalable infrastructure, the age of traceable communication may quietly come to an end. This has been Dose of Dossier. I'm the informant. Stay curious, stay vigilant, and remember, the most powerful systems are the ones you can't see.